en el chat.
Okay, good morning. We're going to proceed for the defense of the doctoral thesis of Capitán and directors are Capitán and Recruiter. So when you want, your presentation.
Okay, good morning to everyone. Thank you for coming to my doctoral thesis dissertation. That is called Threat Management for Mission with a multiple unmanned aerial system operating in the use space. The presentation is divided in 6 sections. The 2 first sections are related to some introduction and background needed for understanding the 3 main contributions of this work. Section 3, 4, and 5 are the 3 main contributions of our thesis. And the last section is for conclusion and future work that we have considered. First, starting with the introduction, it is well known by all of us that there is a tendency of use more and more UAS for many commercial and civil applications in the very low level airspace. For example, for monitoring sport event, monitoring concert, inspection infrastructure, and this precision agriculture use cases, and so on. This growth of the UAS sector brought us the challenge of integration all these UAS into the ATM, traditional ATM concept. This is a big challenge. It could be considered the most challenging thing since the ATM concept started with a commercial aircraft. For that, it is very, very clear that it is needed new regulation and new structure of the airspace in order to adapt this UAS integration into the airspace and to meet the UAS requirements. In this slide, I wanted to highlight the different objectives that the thesis have and the different publications that we have done in Congress and journals. The first objective is to analyze the European Union regulation and also the use-space framework before developing our contribution for managing multi-UAS operation in use-space. The second objective is to build a framework for a managed aerial traffic management system in the frame of the use-space concept. The third objective is to build a methodology for automated decision-making in order to handle unexpected events that can happen when different UAS are flying in the use space. And the last objective is to validate the developed framework that we have done in this work, both in simulation and also in real experiment field trials. Then we have here some additional publication, and also I wanted to mention the projects that gave me the opportunity of make this work. The core development of this thesis had been done under the umbrella of the Gauss project. That it is an European Union project funded by the GCA that now is EUSPA, Then the multi-drone project, that it is also a European project funded by the European Commission. It is also it was very useful for one of the contributions of the thesis, and the USEP project and multi-COP project, where thanks to this project, I had the chance of making a 3-month stay at the University of Southeastern in Norway. So speaking about some background in the regulation topic, we have new packages at the European Commission related to UAS regulation and also related to use-based regulation. You can see here all the packages, but the most relevant thing that I wanted to mention is that in the package of UAS regulation, there are a division or a classification of the UAS operation depending of the principle is that you have to consider how risky the UAS operation is, and the regulation divided or classified in an open category UAS operation and a specific category UAS operation, or as UAS or a certified category UAS operation. In our thesis, we are going to be focused just in a specific category. All the use cases and all the things that we have developed are considered inside the specific category. This specific category, the framework of the regulation said us that it is mandatory to make, before starting the operation, a risk assessment of the operation, and the methodology that the regulation suggests to make is the specific operation risk assessment, also called by the acronym SORA methodology, that you have to submit before and get the approval before starting the operation. Then some background about what is use space. Use space is it can be defined as a set of services for integrating in a safe and secure way the UAS into the airspace. This use space initiative is divided in 4 phases: U1, U2, U3, and U4. Depending on how more advanced you are in the phases, more level of automation and level of connectivity with the ATM you have. Every use space phase was defined at the beginning in the foundation by different use space services that you can see here, different services that every phase is composed of. The services right now, because the use space is in developing, as you can see here, the timeline. There are new services. The name are changed. So this is the foundation of the name of the use space services. Then I wanted to mention this is coming from the regulation that we said that we have a use space framework regulation that will apply from January 26th of this month. In this regulation, it is defined 2 relevant entities or roles that are: one is the Common Information Service Provider, or CSP, and another one is the Use Space Service Provider, or USSP. As you can see here, well, first I'm going to define what is what. Common Information Service Provider is an entity that have to be certified. Normally, it's a national entity, and it is in charge of of declaring at the airspace, normally in a national part, to declare the U-space airspace. When you have an airspace, then the CSP can define the U-space airspace. It's in here, and it is also the single source of truth in terms of U-space. Okay. Then we have under one CSP, we can have several USSP, and the USSP are entities that have to be certified also, and they are in charge of providing U-space services to the stakeholders. For example, an example could be that one USSP could be AirMap or Unifly. And here in Spain, for example, a common information service provider probably will be Enaire. You can see that there can be some bidirectional communication between them. In this slide, I wanted to make a mix between the UAS, the phases that the UAS operation have. We have a pre-flight phase, we have an in-flight phase, and a post-flight phase. And also we have different U-space services that we mentioned before. In our thesis, we are going to be focused on U-space services that we need, or we consider that are needed for the threat management or unexpected event management in a U-space framework. These services are tracking, monitoring, emergency management, and tactical deconfliction. Also, you can see here that before getting the approval of a flight, it is needed to pass the SORA methodology. The first main contribution that we have done in this work is to apply the SORA methodology for a small group of UAS working autonomously in a media production use case in the frame of a multi-drone project. We have applied SORA methodology in this use case. SORA methodology is the version 1 was 12, because there are different versions of SORA. The version 1 of SORA is a 12-step methodology that you have gone through all of the steps. Try to evaluate if your operation is safe enough in order to get approval to fly. In a simple way, I wanted to show here how is the methodology. First, you need to define how is the concept of the operation that is going to take in place. Then the SORA evaluates the risk that the US operation have depending with the ground. How then you calculate with different tables and so on. You calculate the initial ground risk class, that in our case was 3. On the other hand, SORA evaluate what is the air risk that your operation can have. So in our use case, this number was, or this metric was air risk class. It was number 2. Then, if you have some mitigation action that in the operation, the concept of the operation that we have assessed, we have 2 mitigation actions. The drones had a parachute, and also we define in the use case, or in the use case, we define an strategy and a volume where the drone have to make the operation. So this mitigation measure gave us the opportunity to reduce in one unit both metrics, okay, from 3 to 2, and then with these metrics, SORA in the table give you the measure of the specific assurance and level and integrity level. That is the SAIL. Is the SAIL in SORA can go from 1 to 6, being 1 the most safety result from SORA, and 6 the more dangerous output from SORA. Then SORA, when you have the SAIL calculated, it is provided different operational safety objectives. Some of these objectives are mandatory to be accomplished, and another one are optional. In our case, they were all optional, so there were not need of changing the concept of the operation at the beginning. So it was considered that the operation was safe enough in order to get the approval. As I said before, we have one version, SORA version 1, that we apply. Then we updated our calculation to SORA version 2, and now in this moment there is a SORA version 2.5 that it is open to comment, and it is expected to be published in 2023. So some comment about our assessment of regarding SORA version 1 and SORA version 2 is that in SORA version 1, it is they just consider the risk assessment for operation that it is a single UAS. So it is not considered a swarm or a small team of UAS making an operation. So we found a lack of intrinsic risk that can have a small team of UAS making an operation. In SORA version 2, they already mentioned about swarm, but they mentioned that a swarm is a team of UAS with a special relation between them, but not with a third party. They consider that there is another third party that have to support to get more safer the operation. So it is not. It's like it is not needed a UTM system or whatever. Going to the second main contribution of this thesis is section 4. As I mentioned before, we have built a framework for unmanned aerial traffic management, or UTM, in the context of U-space. We have defined the architecture that it is service-oriented architecture, it is digital, it is flexible, and it is modular. The architecture have been designed focus in or trying to focus in focus in because the last objective was to handle unexpected event that can happen in the use space. So we focus our architecture in these last objectives. That's why in the architecture that you can, the functional architecture that you can see here, the emergency management module is in the center of everything, because the emergency management module is the one that handles the unexpected event that can happen. When I say unexpected event, it's the same of threats. Okay. These architectures have been implemented in using ROS that has a middleware that you can use Node services and topics. And it is focused, as I said, in new space services and needed for threat management. Why is open source? Because we have used ROS, that is open source. We have released our architecture in GitHub. It is digital. It is digital because all the experimentation that we have done have been via internet. Why is modular? Because every module that you can see here you can add some functionality, you can change, and you can add more modules in the architecture. And why it's flexible is because, for example, for detecting threats, we have used one algorithm that we take from by the community, but you can use another one in order to detect conflicts. We use, for example, an algorithm in order to calculate different alternative trajectories that you can have in order to resolve a conflict. But you can adapt the code in order to use another algorithm. Just going to the architecture, we have in green the use-based services that are ROS nodes that they are tracking. The objective of tracking is to have the position of every UAS and the predicted position that the UAS is going to have. So tracking service have to report a position to the monitoring service. The monitoring service is the one that is in charge of detecting conflict between one UAS and another UAS, or between one UAS and a volume, or a geofence, or something like that. Then monitoring and service is in charge of communicating to emergency management module what threats are in the use space in that moment. The emergency management is the module that is in charge of considering the different threats that there are in the airspace and consider the different UAS operations that there are in the airspace. Have to decide in an automatic way what mitigation action have to be done in order to resolve the threats. Tactical deconfliction is a module that gives support to the emergency management in some cases that are needed alternative trajectories for the drones. So tactical deconfliction provide with different alternative trajectory for emergency management that will be the one that get the optimal solution. Here we make a simulation of the architecture working. We have defined 2 use cases with all the functionalities, and we prove the concept by simulation. The first use case is that the UTM have to manage a loss of separation between 2 UAS operations. One UAS operation is the green one, and that it start the operation on time. It's a fixed wing UAS, but the UAS in orange delay on the operation. So this delay show up that the monitoring service detect that in the future is going to have a conflict. So tactical deconfliction and emergency management services, both of them decide what is the best solution in order to avoid this loss of separation threat. The other use case define the UTM have to manage a jamming attack and a geofence conflict. In green, we have a UAS that is making a wind turbine inspection, but this UAS suffer a jamming attack. So emergency management create a geofence around the jamming attack. So this geofence that you can see here now in red enter in conflict with the other UAS that it's flying in that moment, and tactical deconfliction and also monitoring, and also emergency management, again decide what is the best option in order to avoid this geofence and not enter into the jamming volume that it is declared. Passing to the section 5, where is the contribution of the threat methodology that we have developed. We have built a real-time decision-making method. Real-time because we have validated in the UTM before that this is working in real time. Decision-making is automatic decision-making, and we provide to the UAS operator with our output, and manage threats that can happen when several UAS are flying in the use space. First, we identify a set of generic threats that can happen in the use space. We identify them, and we classify these threats. This threat depending how danger can be the threat in the use space if this happens. Also, we define possible actions and maneuvers that the UAS, possible action that our UTM system or our methodology can provide or suggest to the UAS operator, and possible maneuvers that the UAS can make. For this output, we have considered a multi-objective function that I will show later on, and we have validated. We have fully integrated this methodology into the UTM framework that I mentioned before, and we have validated by simulations and also in real experiments with real drones. This is a simple scheme about the methodology. First, you need to define again the concept of the operation. Then, as I said, we have different threat types. Every threat have associated a severity. Severity means more danger or more damage you can have if this threat happens. On the other hand, we have different UAS operation in the airspace, and every UAS operation have associated a priority. For example, a rotary wing, a fixed wing UAS have more priority to fly than a rotary wing UAS because of the maneuver of the UAS. And also you have different use space constraints to consider, like geofences, no-fly zone, the altitude of the very low level, and these kind of things. Then the methodology have 3 possible mitigation actions. The first one is to send a specific command to the UAS operator, for example, land now. The second possible mitigation action is to create a geofence, for example, to isolate a threat, like isolate a jamming attack. And the third mitigation action could be provide the optimal alternative flight plan. How it's provided the optimal alternative flight plan to the UAS operator? Well, first we define different maneuvers that all the UAS in the airspace that are flying can have. Then we define metrics for measuring the riskiness and the cost of making these maneuvers. We calculate alternative flight plans, and then we evaluate what is the best alternative flight plan for the UAS operation that we consider. In this slide, first we have a table of the maneuver that we are consider in order to solve the conflicts, and then we have here the function that we have minimized in order to get the optimal solution. This function is a multi-objective function because we are evaluating in one way the safety of taking a maneuver, and on the other hand, we are considering the efficiency of making a maneuver. So it is important to mention that depending of what are the weight that you have in the function, you are going to have different results. So we have predefined giving more. We have predefined these weights, and we gave more importance to the safety that they are beta 1 and beta 2. The sum of both are 0.6, and the alpha is 0.4. Of metrics have been defined. One is the cost metric that evaluate how costly the maneuver is with respect to the initial flight plan. For example, the definition of cost metrics, the distance to be traveled. This I need to travel more than it was to travel. So this is a cost. Then two riskiness metrics defined. One is the risk number 1, that is the length in meters of the new flight plan that is still in the conflict. As much you are in the conflict, less safer is the operation, because you are still in the conflict. In metric risk number 2, we define this metric as the minimum distance in meter of the new flight plan from conflicting situation. That means that the farther you are from a conflicting situation, the safer is the operation of the maneuver. Then we in this slide, I wanted to highlight the setup that we made in Atlas Center in Jaén, Spain, for validating our methodology and our UTM system with fixed wing and rotary wing UAS. You can see here the UAS, the people working in the experiment. Here you can see the UTM computer and the ground control station with the people that were pilots of the UAS. Also in this scheme, we can see that what is the scheme of communication with other partners, because this experiment was made with Everest and Satways and other companies. This was, for example, developed by Satways. Our part was the methodology implemented in the UTM system that was communicated with the other partner via MQTT protocol via internet. Here we have defined use cases for the showing the result of this experiment. You are going to see a mix of real flight with the RB visualizer make-off with the result of the experiment. So for the visualization, we use the result of the real experiment. stop. The first use case is, again, a violation of safety distance between UAS. In this case, we have, again, a fixed wing and a rotary wing UAS. We have here the start of the operation of the fixed wing UAS operation. And the rotary wing UAS have a delay on the start of the operation. Then the monitoring service detects that in 4-dimension spatial and time, it would be a conflict. And tactical deconfliction will provide different solutions. In this case, for the UAS that is less priority in the use space. And emergency management calculate what is the optimal solution that we can suggest to the operator, and the operator accept or not accept the proposal of the methodology and the UTM system. The second use case is that it is declare a wildfire in a location. So so emergency management declare a geofence very large, and this operation that is taking place here is just have to be, the drone have to leave the wildfire location. So tactical deconfliction provide different alternative flight plan. And emergency management provide with the most optimal the optimal solution in order to leave the geofence. This last use case was there is a conflict between a fixed wing UAS and a rotary wing UAS. In this case, the rotary wing is the one that suffered a jamming attack, and the fixed wing UAS that is making in the operation have to avoid. In this case, a fixed wing have to avoid the geofence created by the emergency management. The last section of the thesis is the conclusion and the future work. Some kind of a result that we have done. We have analyzed the regulation and the use space framework. We have described and implemented a SORA methodology for a multi-UAS application for media production. Sorry. We have built a service-oriented digital, modular, and flexible architecture for UTM in the context of use space. We have designed and developed and implemented in real experiments with real drones, considering fixed wing and rotary wing drones. Methodology for automatic decision-making to handle threats that can happen when different drones are flying in the use space. Also, as a conclusions, we found different problem in the experiments. One of the problem was that it was a lack of loss of communication between the ground control station and the drone, loss of telemetry. So if we lost in the UTM system the telemetry, we cannot take actions. So we think that it is quite relevant that for this kind of application, it is essential to have a reliable communication infrastructure based in 5G technology, especially if you are working in an urban environment, because our development and our experiment were done in a not populated area. But if you go into the city, the communication is going to be more saturated, the telecommunication infrastructure. Also, in terms of scalability, we have used one UTM server. We have make experiment with 2 or 3 UAS. But if you want to escalate this solution, we think that it is better to escalate not vertically using a more powerful servers or computers. We think that it is better to escalate in an horizontal way, using, for example, some tools like Amazon Web Services, where you can use different servers located in different points in the world. Also, there was a thing that we realized making the simulation and also the experiment, is that it is quite difficult to get conflict in 4 dimensions, spatial and time. It was quite difficult to get the conflicts and to solve it. Also, making the work of the SORA methodology, we think that it is missing some tools that are more automated tools in order to pass the SORA methodology. That is something more or less easy. You can make some automatic manner of making this risk assessment before the flight that are related to SORA, and also as far as I know, there is not any methodology in order to make risk assessment during the flight when the drones are flying. And finally, our method considers fixed wing and rotary wing UAS, but nowadays it is a hot topic, the urban air mobility and the use cases and the application of urban air mobility into the city. So there are more vehicles that are flying. We can see in the news in the airspace, and it could be a future work to adapt our methodology to electric vertical and takeoff landing vehicles, air taxis, or convertible drones. So this is all from my part, and now I'm open to any discussion that we want to have. This video is just to see.
Okay, thank you for the presentation. So now we're gonna open a round of questions, queries, whatever. So we're gonna start with Niklas. Niklas, do you hear me?
Yes, thank you for the honor start. I hope you can hear me clear.
Okay.
Yeah.
We can go.
Very good. Yes, a very good and clear presentation. Thank you for that. I have a couple of questions, and I start with the most obvious one. What do you consider to be the most important contribution of all these contributions that you gave? You identified 3 important areas in your work and also a couple of very interesting new innovations. What do you consider to be the most important of all of these points?
Okay. In my opinion, the most important contribution is that we have, the threat management methodology is in flight phase. This is the most important contribution. The thing is that for that, we need to build the UTM. So the most important contribution, in my opinion, is to the real I'm going to see like this. The experiment and the proof that we have done in experiment in real experiment with real drones of a methodology that can handle unexpected event that can happen when different UAS are flying. This is, I don't know if I answered your question.
Yes, perfect. Thank you. One second question that came to my mind is you concentrated on a specific implementation in the U-space concept. And do you think that your work could also be applicable to other UTM systems, like, for example, in the US or in the Asia-Pacific area? Because they are a little bit different from the U-space concept. And I wonder if your results could be applicable there too.
Yeah, the more that the one that I know more is the USA solution, and they define we in Europe we name this concept at U-space, but in United States they define this initiative as a UTM NASA UTM. If you see, they have also this initiative divided in 4 phases with different level of automation, and this at the end I'm going to say that here in Europe because we started later than the United States, we copy or we have as a inspiration the NASA UTM, but we changed some names, we changed some services, but at the end, the problem that we need to solve is the same. So this contribution that we have making is generic. It is true that it's focusing the U-space concept, but if you change the name of the things, at the end, the important thing is the functionalities that you are providing to the community. So in Europe, there is we are studying here some several operations, some services that provide a solution when threats happen. But you can go to United States and you are going to have the same. Several UAS, some functionalities that you need to name in another way and provide solution to conflict that can happen. I think that our contribution is generic enough to adapt to other initiatives, like you mentioned, for example, the NASA UTM, or the other one that I don't know very well.
Yeah. Okay, thank you. I totally agree with you that it's kind of a generic contribution that you gave here, and also that you mentioned the threat component. It should be adaptable. My last question for now, I don't want to take too much of the time, is on slide 17, you mentioned that there is a trade-off between efficiency and safety in your multi-objective function. How do you decide on this trade-off? And my more specific question here would be, wouldn't a multi-stage process here better to first decide on a couple of safe solutions, and then in a second stage select the most efficient between this, instead of mixing this up in one step?
Well, it's an approach. It's an approach that you are proposing, but we decided to make it like this because one of the principles of building a UTM, it is that the UTM system have to be safety centered. So that's why we, as designer, we consider to prioritize safety instead of efficiency, because the principle of the definition of a UTM system tell us this. But it is also that important that you get a compromise between getting to finish the operation and be safety centered. But it is true that another approach is the one that you mentioned about considering first safety and then efficiency. But this is why we make it like this.
Okay, thank you. That's it from my side for now. Thank you.
Thank you to you for being here, Niklas.
Thank you, Niklas, for your contribution. So now next turn to, let's start to Christian, please.
Hello, Carlos. Thank you for the work, the presentation. I found the presentation very informative. Also, your thesis, I do like the open source approach, and you are saying your contributions to the community. It's not always the case, and it facilitates that all the community can adopt this research, and that is very valuable. Something was interesting for me in your thesis. I have to say that you use a lot the we, our, and it was something that it was interesting. But I think for next time it would be better to try to put in a passive way or something like that, because at the end it's your research work, and it can, for some people, can be something interesting to read in that way. But in any case, I do agree with you with the innovation from your side, going from a theoretical framework of all the content of operations to an actual validation or at least this demonstration of feasibility of the concept. And there are much larger projects than CAUS and other trying to do this kind of things, and they are involving much more resources than CAUS. And I do value that you manage within the CAUS project to do this, and all this organization, the administrative part, the technical part of this kind of flights is really heavy, and I think that your thesis doesn't show so much how expensive, how in terms of effort. So, but I know that, and I want to highlight that. And so you face a challenge here, and it's that all the concept of operation is evolving. Okay, so I saw in some slides that you are referring to the services of the CONOS of the first edition of the of code, for example, or the US-based blueprint. And my first question for you is these methodologies, in your view, are compliant with the new regulation that you have said correctly, that are going to be enacted, not enacted, but in place from next Thursday, 26th of January. Do you think that this is still valid, or you will need to refine some of the services?
It is an easy question because regulation doesn't consider yet tactical deconfliction or the manage of threats in flight operations. The regulation just consider the one that is going to be approved now. Just consider, just in memory, the flight registration, just see the US in the traffic information, but there is not considered yet in the regulation that is going to be approved in January. It is not considered yet any strategic or tactical conflict management. So, as I see, because I'm right now working in the private company developing this kind of concept, as I see, I try to make in the company just to be in advance of the regulation. But at the end of the company, they say, no, the law is the regulation. So we need to accomplish the regulation, and then Carlos can think about the other things. But I think that our work, I try to pave the way of. That's why I would like to. Well, I try to get to more people to know that there are things that are already, because I see in some projects you mentioned that they say that they have done a tactical deconfliction service, but then you ask some question, and then no, the pilot decided just to in a manual way, not in an automatic way.
That may pave the way for my thought. Sorry. That may help for the next question. Probably one of the main objective of a UTM or US space would be to build situational awareness for the remote pilot, because at the end the regulation at this moment doesn't identify the UTM service as a possible separator. You know, I mean, because in your, I don't know, in your slides when you were putting the different actions that the UTM, I think was the previous one, this one, yeah. No, the previous one. Sorry,
where are we?
16, I think.
16.
This one, yeah. The issuing specific commands from the UTM to the aircraft, to the unmanned aircraft, right now is not
possible.
Authorized. It's not possible. So at this stage, do you think that this system, if once we can avoid the rigidity of these regulations, do you think this kind of systems would be safe enough in order to remove these remote pilots from the equations? Because right now, my view is that all regulations, all approaches to UTM are maybe a little bit biased by the ATM practitioners. But do you think that this kind of systems could remove this remote pilot from the equations and maybe facilitate the adoption of broader urban air mobility, for example?
Well, it's totally true that the regulation doesn't allow to fly in a, well, I said that the UTM system provide with a suggestion to the US operator, and the US operator have to accept or reject the suggestion that you make. In the base of the definition of use space, if you see an ideal feature, they want to, well, they define like automated, the most automated way of managing the US into the airspace, and at the end, autonomously. I see that very far away in terms of safety, because we see that there are different experiments, and you see some accident, for example, in Plaza España in Seville, with multiple drones making a making something. I think it's autonomously working. I see this far away. I don't know if it's happening or not happening. But we are contributing and providing more automated ways for solving this, because at the end the concept of UTM appears try to solve that there is a problem in the ATM that is the communication in the ATM are by voice between humans. So there is some kind of a bottleneck for escalation. So the UTM try to be digital in order to avoid that you need so many people to communicate by voice and take decision to solve or to manage the traffic. So my answer is that I don't know if we will get autonomous operation, but we are contributing to be more automatic communication operations and management of the operations.
Okay, thank you. I have a lot of questions, but I don't want to provide that in the session. So just on the cost side, again, because I think it's the next slide. You define my two questions are okay. So you define the cost as a matter of the distance to your flight plan, or to you plan, as it is now said by the correspondent. I don't like the name. So this EU plan, but I don't know what is your view, or how would you include more the view of the airspace user or the operator here, because is the distance to the flight plan the only way to determine the cost to the operator, or would you include any other parameter or element of this operation?
Well, I didn't think about that. Well, there is here some divergent things, because when you go to the theoretical definition of U-space, you are trying to make a decentralized way of managing the airspace, that like the US operator can fly, I will say, I say in the UTM platform, this is occupied, this is not occupied, I want to go to there, so I submit this flight plan and I get the approval of the UTM. This is a distributed approach, but then you go to the regulation, and the regulation say that there is a centralized, that is the USSP, that provides services to others. So it's a good question. I didn't put the hat of the US operator to think about how can be better for me to submit or to define this function. I put the hat of the emergency manager, like you know what I mean?
Yes, that was my impression. I think that, as I said, we are really biased by the ATM, and the ATM is just one use case where we are transporting people or cargo go to one point to another. But in your use cases, for example, inspection of one
turbine, no?
Turbine, yeah. I don't know if that is the proper way. If you are getting far from this turbine, you cannot inspect it, and the cost for the operator would be make it operation again. And probably that is not something acceptable for the operator. And probably something that I would recommend here to you in this kind of equation to evaluate the cost, to include more the view of the operator, because at the end, the operator is who is driving the business, and if we don't think about them, it could be a problem. And that's my last question here on the different possible maneuvers that you are considering. In your thesis, you are considering the computation of the A-star anti-star algorithm for computing.
Yeah.
A-star.
Yeah.
But do you think that is compatible with SORA? Because I don't know what is your view. It would be better to have pre-compute emergency maneuvers in order to get to a safe place, rather than online computation. What would be your preference here?
Can you repeat the final?
Yes, I mean, do you think it's something that should be done strategically? I mean, before the operation, to have potential ways of avoiding or leaving a defense, or is something that should be online during the flight?
Well, first, I wanted to mention that the algorithm implemented for calculating the different alternative flight plans, it is not my contribution, okay? It is mentioned in the thesis. That is a contribution of one of our colleagues that was working in the Gauss project. But so I don't know very well how this algorithm is working. This algorithm is working in computation terms. But I think that everything should be made on cloud. That's why I mentioned about Amazon Web Services, because you get more, well, you go to the definition of the digital, and we can have more computation power in the cloud. I think that should be all made in the cloud. You asked me about some relation with the regulation?
No, it's not about the regulation itself, but as in the SORA, they say as a strategical mitigation to or maybe a way of reducing the likelihood of a hazard developing into a harm. And I don't know, because if you have an online service like that in order to compute all the emergency maneuvers for avoiding say, for example, it might be that you need to ensure, to certify, to all of these aspects that are very costly. Okay, for a private company, I don't know if it is worth to put all that money for a system that needs to be maintained, and at the end, maybe you could have some pre-computed or pre-calculated emergency maneuvers and just go to a safe place here.
Well, I was just speaking with my parent about that. Personally, I think that all this that we are developing in the use space is quite difficult to accomplish. It's like how come this may, because you try to, for example, we are trying to make some experimentation in the, well, we try to make an experimentation in the Plaza España in Gauss project, and it was impossible due to the regulation. But I think that if the European Commission is putting a lot of money, and all the companies are growing and putting a lot of money, I think that this use space initiative have to go further, because we are seeing more and more drones flying. So I don't know when, but I think that we will find a way. But it is true that our technical development are always faster, are going faster than the regulation. if you see the regulation justifying for services, the most, the most simple ones. But maybe for the companies, it's very difficult to accomplish with all the regulation, that privacy, cybersecurity, and all these kind of things that you are not, that you even don't know that's happening. That because it's not, for example, cybersecurity. No, if you have an application in a website, you have to consider cybersecurity. It is not my field of knowledge. Then I can make something, but then an expert in security came and said me this is totally unsecure. So, well, I don't want to stay more in there.
Thank you. So I have finished with my questions. Thank you very much.
Thank you.
Thank you very much, Christian. So next will be please.
Thank you very much, Carlos, for this thesis and your presentation. I think there's a lot of work. I think that the good thing of that was putting the stress of the things that you did, and also summarizing all of this, say, extensive work. I have several questions. Maybe I have 4 pages of questions. However, yeah, I will focus on those that I think are really important. Okay, I come from the Agency for the Space Program that has funded the dashboard. So I have questions first general about this framework. So this work that you have developed is done under within the House project, and whose main objective is to leverage high performance positioning functionalities space operations. So my question here is, how is this thesis contributing to this objective? I know that the project is very, very big, and you are contributing to that. And for me, I would like to hear from you why your contribution is to try to go to achieve some of the objectives or the main objectives that Gauss is proposing.
Well, you are here because for making this question. I knew that you were going to make it this question. Well, I agree with you that the focus of the Gauss project is to implement Galileo solution, and how the Galileo solution can provide with a better solution for the integration of UAS. Project, but it is also true that, for example, it is also true that this was our contribution. Okay, in the well, maybe I cannot give you the answer that you would like to hear, because I was not the coordinator of the project, and I was not the one that developed the Galileo solution. But I can give you, I can answer you with what I know about this. In this part, we get telemetry from the UAS. Okay, so we get on that point a message with the telemetry from the UAS, and this telemetry was calculated by the University of UPC. The UPC was calculated a a solution in the drone with considering Galileo. Okay. So our input was already considering a Galileo telemetry. Okay, considering Galileo, different channel and so on. I don't know, because at the end, the objective of the project, I mean, for us, this infrastructure, UBC, get the solution with Galileo, but I don't know what are the final conclusion if Galileo is improving the performance in this kind of solution or not.
I'm going to ask the question in a different way. If I remove your contribution,
The microphone.
I will ask you the question in a different way. If I remove your contribution from this project, what would be the impact? So your contribution is enabling these operations to be safer. It's enabling so I would like to understand from your point of view. Okay, so my thesis contributed in this way to this work, because this was not done. There is a regulation, and so I would like to list for you. I went beyond what was planned the regulation, because you foresee that this can be the way to implement the things in the future.
Our contribution give you the UTM system, or provide the UTM system for the solution. So you can operate with different drones and validate how the GNSS solution is working. If you can delay the contribution, you can do it. But then, if you want to assess how is performing Galileo or improving Galileo with different multiple UAS flying, then you need to set up some experiment with different pilots flying in an automatic way or a manual way, and then see how just taking telemetry, but just to make all that we have done automatically, you have to make it manually. Like now there is a conflict, then the pilot go to there, but you have to make everything manually. This is the difference between because at the end, if you want to perform how Galileo is.
Okay, I have. It was simply a general question. Then I would like to ask you some other questions related. I was saying that my question was simply a general question about the framework. And okay, with respect to the part of the discussions of the multi-UAS operation, focus on film outdoor event in rural scenarios. So, what was your motivation to choose this application and other that are mentioned in Dallas project in general?
Because this contribution was under the umbrella of the multi-drone project.
Okay.
So in that moment, I was working in the experiment of the multi-drone project. So you know, in 4 years of the doctorate. This specific use case was one of the results of the multi-drone project. That's why.
I have several questions, but one of them is related.
Again, no, it's working or not?
No, it's
Ah.
Otherwise, Nicolas cannot
So I don't see that. I inspired for you. Yeah, okay. So, yeah, with respect to this use case that we're analyzing, okay, you were mentioning that this was under the first standard scenario defined by EASA. And then I saw in the thesis that you mentioned two standard scenarios, STS1 and STS2.
Mm-hmm.
And so this one corresponds to STS1 or STS2.
Well, I don't remember.
Yeah, because for me, I was reading and what I saw is that the STS1 is for V loss and STS2 is for V loss. So then in your scenario was
visual line of sight.
Was visual.
Visual line of sight in a not populated area.
Okay, because I think that in the text, and that's why I'm asking, I think that in the text at some point you mentioned VB loss.
Yeah.
So, and that's why I was confused. I was okay, simply, I was thinking if it was okay, possibly that there is you mentioned that this work, okay, you were analyzing under SORA different versions, and then did you finally submit it?
No.
For operational approval?
No, it was a theoretical. It was a theoretical work. We didn't submit the.
Oh, and aren't you curious about if it would be approved?
Sorry?
So, I mean, you didn't submit, but aren't you curious about if it would be approved?
Oh, yes, I'm curious yet, but.
Haven't you contacted any company that may be interested in this case, and then simply say, okay, I already did the analysis. Is it okay with you? Can you confirm, or can I would like to see if it is if you have thought to move forward with this work to make it a practical thing?
Well, I will love to do that, but for that you need the resources, you need the funding, and you need for passing all the hell of going to the regulation parties.
I have some questions. Okay, so you mentioned that this was done before the Gauss project, so then inside the Gauss project you didn't do any other risk analysis, right?
No, the risk analysis was for the multi-drone project.
I was hesitating, I was thinking about if when I was analyzing the measures, and I didn't see the way you consider GNSS to support the safety case. So have you considered that? Because with GNSS, okay, you can have several receivers, you can have constellation receivers, you can have integrity with protection levels in position provided by SPAS, you can have high accuracy provided by Galileo, high accuracy service, by RTK. So have you considered, okay, GNSS at some point?
Yes, in one of the threats that we have considered, we have defined if the loss, well, the degradation of the GNSS.
Yeah, because you mentioned jam, spoofing, and degradation. You mentioned these three.
Yeah, you are reading the threats, no?
Yes.
Yeah, the threats. the GNSS, but we didn't far in deep into the term that you mentioned about integrity and performing. I remember at the beginning of my thesis, try to go in too deep in this, but at the end we didn't go inside all the positioning.
Spoofing, you mentioned that it's difficult to detect.
Yeah, you were talking about the spoofing.
Yeah, in your thesis, you mentioned that it's difficult to detect, and
correct.
We are working in a new service that is going to provide a mechanism of indicate the availability of the information that you position.
Mm-hmm.
And also there are some other works related to encryption. Also with respect to GNSS degradation, this is for spoofing, and then for GNSS degradation, we have different services providing different frequencies. And the degradation of the signal is normally happening in E1, L1.
Mm-hmm.
However, this E5 or L5 is not that, I would say, subject to these interferences. I'm mentioning that because I think that this is important also that you take this information also in the Gulf project, and you take this information into account. Okay, so that there will be more ways to provide the measures to mitigate this risk.
Uh-huh. And these are new use-based services that you are proposing in your project?
Services that some of them are already in place. For example, Galileo Open Service is providing their information frequencies, L1, L5 frequencies. With respect to spoofing, we have just published information related to how the service would work. Basically, we provide the information about how to check that your signal is, or the information that you get, you can check that it's coming from Galileo or not. It's coming from another source.
Mm-hmm.
Okay, so this is something that we have. There are some difficulties about real time. Okay, this is another thing. But okay, we are working on that direction, and we would like to know how we can contribute to this problem. Okay, so this is something that we are always interested in knowing what are the user requirements, how we can make our services evolve so that they contribute to some problems, and drones are one of the applications that we are focused. Okay.
Well, how can be useful this for that is just if in the interface that we have between the UTM system and the drone, if you add in the message parameter specific about the Galileo solution, we can have into consideration and make, for example, another module or just in the emergency management module, the GNSS degradation, add more functionalities, because right now just consider there is a GNSS degradation, yes or not. But if we have more input, more parameter input, we can evaluate adding some functionalities to assess how much degraded is the is the signal, for example. It's just we need more data coming from the interface, and in my case, more knowledge about what is important to know about integrity and this kind of concept.
For me, it's important the two things. One is first, for me, it's important. One first, the part of the safety case, how, and the second part is about the threats management. So I think that that they can contribute, but okay, there is a need to go for an analysis. Basically, I think that this is a future work that could be done. I wanted to move to the final part of the thesis now and ask a couple of questions. The cases where you are considering in this, in the last part of the thesis, two drones involved.
Yes.
How scalable is your methodology and also the use of this equation to have more drones involved? I know that for the formula that you can use and UAVs.
Yeah.
My question here is, have you simulated that for a higher number of drones?
No, we have simulated the use cases that I showed, because that were the one that was defined by the project. But our solution is escalated to more drones. We didn't make this escalation, but imagine that you can make a simulation with 10 drones. No? It is totally feasible with this approach. The thing is that in order to prove our threat management methodology, as I said before, it was very difficult to get a conflict considering for the trajectories and for the volumes. So that's why we focus in try to make set up a simulation or validation setup simple in a way of trying to rise a conflict, because if we didn't have a conflict.
So yeah, I'm asking that because you are normally trying. I mean, you are providing the optimal solution for this scenario, and the point is that imagine that because of the decision that is taken, this one of the drones is implementing a different trajectory, and that means that it's also delayed now because of that. So you have different trajectory now because you need to avoid, and then it takes you more time to reach to the next point where you should.
Yeah, could affect to others.
Exactly.
Yeah.
You will have a cascading effect.
Correct.
And this is what I was thinking. If you have thought that this can be managed in cascade, or it would be better to take all of them in one shot and say, okay, we try to find the best solution for all these that will be impacted.
No, it's implemented in this way. Monitoring detect one threat, then you solve this threat. Then, if another threat happen in cascade, monitoring detect this new threat, and the system again solve this new threat. So you consider the present and know the potential conflict after that.
Yeah, the thing is that the solution that you take is optimal only for these two. Then consider the 3 is suboptimal. It's not the optimal one necessarily because it's constrained by the first decision.
Well, consider the optimal of the one that are flying in that moment.
I was checking the table that you had. I was checking the table that you had with the parameters and the resolution of the multi-objective function, and I saw that the table, the number in the thesis I think was 10, 15 by 10. You mentioned that I see that the riskiness 1 is always 0 in the table. Is that a mistake? This is what it was achieved.
Well,
you were explaining.
I had to see the table, but I think it's not a mistake.
If it is 1, what you are saying is, or what I understand, is that the length of the new flight plan is still in conflict is 0 now, or will be 0. And then here, the value of the parameter.
Well, if you want,
1 and so on, it would be not relevant. Because for me, it's curious that it's always 0. That the optimal solution for all the cases is always 0. This is what I saw. Yeah. And then maybe it's not
what can I?
to have it there, or they will find point there. And I don't know if it is a mistake, an error, or
Let me.
or this,
No.
or this is what is
Yeah, I think it's no. I think it's not a mistake, but I have to remember why it was. So we have defined risk. How different maneuver computed by our method use case 1. Use case 1 was with loss of separation, no? Separation involved in that.
Maybe this value is achieved because of the value of the beta, the selection of the 3 parameters that you were putting. Beta 1, beta 2. So maybe because this is the solution, and maybe if you put some other selection, then you would reach in some case that is a different value for the next one. The point is that it was a surprise for me, and I was trying to see if it was commented, because I think that it deserves something that is curious. No? Okay.
It might be that you are.
For example, riskiness 1 is the length in method that your new flight plan is going to be still in the conflict. Okay?
So it's a good thing. So we are saying that
Yeah.
it's not complete anymore.
Yeah. Okay. That's the answer. When you go down, you are not in conflict anymore. Okay.
So I'm saying that,
it's okay.
This is what I understood as well.
Yeah, it's
okay,
good.
But I think that the comment explaining that.
Okay, I'm sorry. I was trying to remember and.
Okay, I have no more questions. I think it was a very interesting work, and I read it really with a lot of care. So okay, I would like to congratulate you.
Thank you for your questions, for being here. Thank you.
Okay, thank you, Manuel. So next questions from Arturo.
Okay. So first, I want to congratulate you and your directors of this work. I've known from close at least the first steps of this thesis as a multi-UAS project. But well, I have some questions. Some of them have been already covered by the colleagues. But still, So you mentioned that the SORA at the moment of the multi-drone experiments and the analysis didn't consider the fact of having more than one UAS in operation, which in the multi-drone project was, of course, an issue. But now, in the new versions, they are considering somehow, but at least mentioning the concept. But even more further than the risk analysis, but in the proposed framework, how do you include the concept of this swarm of this? Because nowadays we have a lot of collaboration between different UAS. For an application, we can collaborate. One could be monitoring, and the other one could be manipulating. I don't know. So how could this be included in your framework?
Well, it's a good question because in my point of view, there is a misunderstanding between what is detect and avoid techniques and what we are developing here. Okay. For what we are developing here are space services that they have to be communicated by internet. You have some delays via communication. The detection of the conflict are detected with more than minutes before the crash or before the possible conflict. So let's say that our method it's in a higher layer that detect and avoid or sense and avoid techniques. So when you for example, if you want to make an experiment with multiple UAS working autonomously or like a swarm, it is needed by regulation that you submit an approval, or you submit the methodology and you get the approval. But you can do this operation without EU space. You don't need EU space. EU space, you can make this operation inside EU space. That at the end of January is going to have when an IDE or whatever TSP is certified, then you can have EU space airspace in Spain, and then you can go there and make this operation. But our level of manage is higher than that swarm management. So this will be my clarification about the difference between what we are proposing.
So I understand that it's not the same standpoint of the reactive on-flight issues or threats, but I mean, how now, like all the missions that you described are single-use missions, independent from each other, and the swarm mission can be more complex because, well, I mean, they could fly closer than these operational volumes or these concrete volumes that the regulation defines somehow. And the here, I mean, of course, the coordination between them should be implemented by the operator and not by the use space, of course. But I'm curious about how this kind of missions or this kind of things could be considered by the use space, because I mean, I can't have like
Yeah, I think it's a very good question because U-Space is not considering this kind of operation yet. As far as I know, they just consider single UAS operation, and then you have different single UAS operation in the airspace. And every single UAS operation have operational volume, and you have a corridor, and so on. But it is not considered as a swarm operation in U-Space yet. What I see in the industry is that it's a bit far from considering that in the U-Space. You see that the SORA, that it is not needed U-Space, just mention the swarm, but without the UTM. We will see what they say about swarm management in there is an event about SORA 2.5. I think that is in February, and I will assist and I will see what they say about this kind of operation.
Just a comment. I think if this is not considered and all these kind of things will be implemented by 2030, so 7 years from now, I mean, we should start or someone.
I'm going to tell you that in my present role, we made a revision of the new concept of operation of the U-Space that is developed by Eurocontrol, and we send a review of all the document, and I mentioned in the review to consider how to consider the swarm because it's not mentioned in the concept of the operation. Now I have to wait that Eurocontrol take into account my comment.
So the connection with the service manager is a critical connection.
Mm-hmm.
Communication, use of 5G networks, somehow, but maybe like in internet connection.
Well, are you speaking about the architecture?
Yeah, I mean, but in general, in the proposed framework, have the service manager is the
Yeah.
like
That is not
the
as
main point of the communications between
the interface.
the interface. The UAS and the UTM system.
Mm-hmm.
There you can publish your positions or get the
Actions or getting the telemetry,
exactly.
input and output.
But this is actually a really critical part of the system because you don't have this communication. You are lost. And on the other side, the UTM system can be lost the connection, the communication with some of the units. Also, you use ROS
Mm-hmm.
test to implement this a way a version of your framework. But cross communication is not the most reliable way to do it in non-reliable communication infrastructure. I mean, if you don't have a good local network somehow, the cross communication is not the best way of doing this. Moreover, they are not encrypted. You mentioned also the cybersecurity issue. So, with both this in mind, you mentioned something before about the experiments and the problem you have. I'm curious, you have problems communicating with this, but first with the service manager from the ground station and more from the UAS to the.
Yeah, we have problem communication here. Well, because if we lost the telemetry, and if you don't have telemetry, then what happened in the experiment, for example, in some moment we lost the communication, and we had already the drone flying. So for example, the fixed wing drone had to loiter in the airspace, waiting to have again the telemetry communication well. And then when the telemetry communication was already good between the UTM system and the remote paleo station and so on, then we could make the use case that we had predefined at the beginning.
Okay, yeah, this was my next question. So how did you handle these issues? So did you just wait, fly until the...
Yeah, because one of the problems was that the fixed wing was very far, so just trying to get closer to the all the setup. This was just the solution. We didn't add another one.
Related to these communication problems, and apart from the possibility in the future of using 5G networks that should be more reliable, do you think that...
Just a minute, a comment about Nicolas, a comment that he cannot see seems that he cannot see the presentation. Try to share the application perhaps.
And so I was saying...
You were speaking of communications.
So apart from using these supposedly better networks like the 5G, more reliable, do you think that a solution like, I think the name is ADSB or something like that?
ADSB? Transporter?
Yeah, I think this is what is used nowadays in the planes. So something like this, not necessarily the same, but some standard that this should be some way necessary or mandatory for the US?
We started in Gauss when I started to work in the project. The company in charge of this, it was Satways, provide us ADSB for drones. There were just one model, as far as I could find in the bibliography or in the market. It was not going along the doctoral along the project. We discard this solution to use the ADSB, at least in my work. In my personal perspective, I think it's not something that is going to be deployed because I don't see mentions about mandatory of using this. This is a transporter to give what is your position, but I don't know. For example, I think this is a technique more sense and avoid, maybe, because we are working with the telemetry. We are sending information by internet, but the ADSB is not working about the telemetry. Sorry, it's not working about internet. But it is. I think in the final solution, it is considered the ADSB, and there is the telemetry between the messages that you get from the ADSB and the message that you get from the Galileo. And one of developed in the project a function of a fusion, both solutions, to get the final telemetry. That it is the input from to the UTM system. This is how we manage in the UTM system. But in my opinion, after all this work, I think that ADSB is not going to. Is my opinion. It's not going to be the used like for all the drones.
So, but then you need to rely on your connection to the system. Thanks. And I see that from the point of view from the UTM system, this is like a lower level and safety measure, so it should be handled. It's not, let's say,
if you use a DSB transponder, you need a reception in the ground, so possibly you will need some of the radars or things that are used in ATM infrastructure to consider more safety in the integration of UAS. But nowadays there is not a standard about how to manage this possible loss of communication.
Okay, so moving forward, just a couple of questions more. So what if the operator, because now you have an emergency, you solve the threat, you send let's say the notification of the issue to the operator, and it's the operator as the final decision of accepting or not.
Mm-hmm.
What if the operator does not accept the mission, and this is actually a new threat?
Yeah, if the operator rejects your alternative flight plan, then the UTM system provide another alternative flight plans, and the operator have to decide yes or not. And then, if you don't have, if the operator decide not to accept any flight plan, then we didn't make this proof this experiment. So we consider that the operator accept the flight plan, but it is a good point.
Yeah, I think that
and it is implemented.
Yeah, you need to consider
Yeah.
on operators. Okay, just one last question about this equation you have with the alpha and the betas.
Mm-hmm.
So you assign some values because you consider that let's put more weight on the things on the alpha.
On the safe risk.
But these values, these weights are predefined. I mean, you have some reasoning about them.
Mm-hmm.
But
yeah, it's
maybe what you think on a way of, say, estimating have a better way of defining these values somehow.
Yeah, it is. It is true. We decided we predefine the values, just a matter of designer decision. But you can add some function here that alpha depends on different topics, and then you calculate the alpha. It is a possible or a good future work to add there, taking into account maybe the use space restriction, the use space constraints. But I didn't think about implement it, but it is a good proposal.
Okay, so that's all from my side. Okay. Thank you for this.
Thank you for coming.
Thank you, Arturo. Okay, it's my turn now.
Mm-hmm.
So, some of them have been already tackled, but I probably will go far in them. And I thought that hopefully most of them will be covered, but no, okay, not of them. And also the interesting discussion that the committee have with you made me have more questions. So that's also, so I'll try to be as brief as possible. So let's start with one just thing that is in my head about architecture. Carlos, you're using ROS.
Yes.
So we all know very well. That's a good point. And it's related with the question. So, but do you ever think that anything made, I mean, relying on ROS is going to be certified by any authority?
No, I don't think so. No. This is a research deployment. You can it's open source. I got from University of Cranfield. I got interest from a professor because he wanted to launch our use cases. We have a meeting with him, try to teach how to launch our approach. But yeah, University of Cranfield was because I suppose that he wanted to make some proof, some algorithm, but certified by a commercial entity. I don't think so. And the architect, as I said before, the architect, I am working in a UTM system in a company now, and we are developing the UTM system in a web service, in a web. It's not using ROS, it's using Amazon Web Services.
So that's the way now that you're working. Is the way that you implies the future. I mean, you see that it's going to be the future or the next future. You're going to be applying web service applications.
Well,
my question is goals. Okay, if I want to move forward, so with the question. Real application. First thing I would should. One of the things that I have to do is just convert it to something that's going to certify, right? So is that the web application service that you're using now? Do you think that that's going to be the way?
Yeah, I think that all the UTM system in the market right now are web application, and they have a mobile application just for seeing for submit a flight plan. But the solution that I see in the competence and all this is web application UTM systems. So this approach can help to researchers to use for using another algorithm to try to make simulation with more drones, try to test more things, but or maybe this theoretical concept can be converted to web platform UTMs. That is what I want to make, but in my role. But right now I'm stopped by the regulation.
I'll talk about regulation also. So then, well, I agree completely. ROS is not reliable enough to do anything with the application of this but also, because going deeper in this, I also have concern about, suppose that we use ROS, like to try to convince authorities not to use it to be defined, but just to see if they can use this, your contribution, for example, in this thesis, to be a proof of concept of what you want to do. Do you think that in that sense also could be?
Well, I think that if I have to convince to someone about what we are proposing, I will speak out the functionalities that we are proposing, the final use case, the experiment, what is the problem that we are solving, what is the challenge, but I will not focus in the middleware that we have used for implementing the solution. I will focus in the solution of the problem.
Yeah, maybe I think in fact I think that you should avoid mention anything like this, in my opinion, because, but yes, I agree. So yes, so, but anyway, in this case, I know that you say, well, I will talk about functionalities and go master level. Yeah, I agree. But at the end of the day, you have to implement that, and the authority has to certify it. So you would not have to go through some.
Yeah, in this case, you have to implement it in a web service.
Yeah.
But you have the the functional definition of at the end we need, because we are making the main contribution, as I said, is what are the functionalities or the different use-based services, and for that we needed some framework to prove, no? So implement these functionalities in another framework that is now a web service based framework. So, but these thesis give you this functional description.
Yes. So related to something that. Yeah, I will go back and then this is okay, that's what the next thing I would like to ask. I haven't seen, maybe because I'm not deep the regulations, but I haven't seen any, apart from the priority that you mentioned at some point, I haven't seen any type of requirements for the UAS system. So, I mean, I know there's a geometry, whatever that you define, and the regulation tell you that, but what about the type of the UAS that you're using? So it's not the same that you are flying with a fixed wing type now, with a multi-rotor, with helicopter, what is the regulation doing about that, and how would you use that?
Yeah.
So,
my first comment would be that, for example, I try to put in the presentation different things that you could not find in the thesis, like and not just copy paste. For example, related to this slide that speak about regulation, in my thesis I didn't make a very hard work in deep into the regulation. This is the regulation that exists, and I wanted to show this because we are working with a specific operation, and it is necessary the SORA methodology. But in terms of considering cinematic or this kind of things of of feature that UAS can have, we didn't consider this. We just consider if you are a fixed wing, you will have more priority. If you are a, well, we just consider this because it's a simple use case. But if we, for example, one of the questions that I was expecting is how your framework can be adapted quickly to electric vehicle takeoff landing or air taxis can be adapted or not. Yeah, it can be adapted because you just define depending on the maneuverable. If you have a magnet aircraft, it's more priority that a rotary wing UAS. But we didn't consider the cinematics or this kind of feature.
My question, Carlos, was twofold. First, I know you didn't consider it. It was clear from me. It's a good first starting approach, I think. But is the regulation saying anything about that? Because my question, for example, like, come to me, you decide you have a conflict, and you decide to plan the trajectory of the units they have a conflict, and you have shown here. So suppose that that US is not able to do it because of its dynamics. It's impossible. It's not achievable. So that's, I don't see any way that the regulation is talking about that. They only care about the 4G by, let's say, the GIF, and that's it. And it's not considered, not only that it's not achievable by the dynamics of the type of the, let's say, the type of the US, but also then taking the development inside that movement variable. So that's the first is the regulation. Have you seen anything there?
I didn't read this other one related. I didn't read it deeply, but I would say to you that I think that it's a very simple regulation that they don't consider this. This consider the weight, but it is feasible to make this operation or the radio for it is not considered. Maybe first because it's a regulation. You put the regulation and then you need to deploy. And second, because I think that in the regulation framework, it is not yet anything about tactical deconfliction or strategic deconfliction. The regulation is in a sooner, a previous step. But I cannot say totally the truth because I didn't read all the regulation.
I mean, it comes to me because I suppose I know it's an yeah, also, but in ATM, obviously, they know exactly how many types of aircraft they have, and they know what they can do. So that it's easy to put like a aforementioned, let's say, path let's say, in times, so they know if it's going to be cheap or not, right? But here I didn't see that anywhere. So I know that in your thesis, you start from the top. I mean, you consider that geometry is for you the wall of the unit, right? That geometry. That's
yeah, this is the fine. That you have to consider flight geometry, the contingency volume, and the operational volume. This is the fine, but this was the fine, I think, in the concept of the operation, version 1, that mentioned before Christian, and also it is defined in the SORA version 1. But I didn't review going inside to the regulation, it is defined in the same way or not. But this deployment of the use space is a process that is going to take years. Like I suppose the ATM concepts took a lot of time. So every week there is new documentation, new regulation, new use space definition. So you have totally, in some moment, I think this is already not updated, because I finished writing in at the beginning of 2022, and now that I'm still working in this topic, I think that I put this that you cannot find in the thesis about that the regulation is going to be mandatory to accomplish in January. I didn't know that when I finished the document. So, and SORA version 2.5, it's I know about this 3 weeks ago.
yeah. Okay, so that's the general recommendation. So what do you know about it? So now coming back to your contribution. So suppose that there is like a requirement that one of these weeks they put a requirement of this, right? So how would you put this into your approach? It would be easy just having a new requirement or not. It would be easy. For example, you will have now geometry plus something else coming from the US.
Well, something that I didn't say is that, but it is here. Our development is focusing, let's say, a UTM system that provides services. Okay, so regulation gives you the framework of that. In January, if you want, you can try to certify as a CSP entity, or you can be certified as a use-based service provider. My approach cannot be certified as a use-based provider. In Spain, I don't know if last week or 2 weeks ago, the regulation entity published what are the requirements to be CSP and USSP 2 weeks ago. I think that is because in 23 of January is going to be mandatory. But I didn't have yet the chance to read this. They publish an Excel for what are the requirements to be CSP and what are the requirements to be USSP. But some colleague of me at work told me that they are not very specific in technical aspects. Que ella tiene el internet, que me está dando internet.
Yes, but
Sorry.
yeah, but talking about your contribution. So suppose instead of the architecture that you have proposed, okay, suppose that you have this type. You have now geometry that you have already and something else. Would you reduce this architecture, or would you need to do, or would you embed this that in this architecture, or would you have to do something else, another module, other functionality to cover that?
I could implement the modules of the architecture. I'm going back. Well, the module of the architecture, emergency management, tactical deconfliction, monitoring, the functionalities. I should implement it in another framework, not in this one, because we said that ROS is not it's not an option.
But suppose that ROS is an option, right?
Then I will need more. I will need more use-based services, because regulation, the first regulation, you need, for example, in the UAS operation, there are different services that are pre-flight. For example, registration the pilot, registration the UAS, strategic flight plan management, strategic tactical deconfliction. All these services are in the pre-flight UAS, in the pre-flight phase of a UAS operation. We focus in the in-flight UAS operation. So we are proposing an approach in it, but we are not considering things that are needed for a UTM system before starting the flight. And again, the regulation is more focused right now in pre-flight phase, like UAS registration, pilot registration, weather information, and if I can start the operation or not.
Okay. Let's see. Now going to the way that you solve it. So first, it's not clear from how you solve it. I think that you are using for that functional input. What is the method that you use to solve that?
It was there is not a method. Yes, you have a low number of UAS in the space. You have just 6 type of maneuvers. So this is a discrete problem. So you need you just have to calculate it like a matrix. No, there is not a method for optimization. Yes. There is not optimization.
Why? So as far as I see, it's just a linear program.
Yeah.
So why would you use that mathematically?
Because it's not, well, it's not the optimization indeed. It was not one of the contribution. I
understand. It's the way that you want something to do like Unmanned and something to do in autonomous, let's say, right? So, but somehow you are, I didn't know that, so now you're telling me that you just put this there heuristically, the best option that you think to experience. So how do you know automating that, right? So it's just like,
well, you have to calculate the different cost metric, okay? Yeah. The risk depending of one UAS can make this operation, this maneuver, this one. So tactical deconfliction is the one, is the module that calculate all the possible alternative trajectories. So he provides to emergency management with all the different alternative maneuvers that these UAS can make, and then with the, as you say, the predefined alpha and this function, then you you just calculate what is the minimum of this equation. So this is how it is implemented. It's not a well. Well, we calculate the minimum value, and that's why it depends. We calculate the minimum value of this equation, but it's not a complete. This is not a complex optimization. It's just minimizing the equation. And why minimization? Because that's why we put all the metrics in meters. The way how we define the metrics, because at the end the better solution was the minimum of all the solution that tactical deconfliction provides us as alternative flight plan, because this is just working when it is needed as a solution an alternative flight plan. Because in the previous slide we have three kind of options: create a geofence, create or send a specific command. This is just working when you need an alternative solution. So this is how it's making minimizing this function and finding the cost as I put in this slide. For example, here this is plus and this is minus because in this case the risk number two metrics as farther you are from conflicting situation, it is most safer. So that's why we put a minus here, a plus here, because if you are still in the conflict, as more time you are in the conflict, it is more dangerous. So it's the opposite. This is the way that we thought about solving this problem.
Okay, so I mean that's one thing that we could explore. I think. Also related with another question. Here is just we have put in there some alpha, beta, right, and so on. So I would just put the whole thing as an activity problem, minimization, as you say, including the alphas and betas. Why your decision is better than one machine with a lot of information that you cannot cope with? So why we always presume that it's going to be better our decision? We could try what they say. What do you think?
Well, yes, you can prepare a set of simulation with trying to use some optimization method that consider these metrics. It is true. I cannot tell you the opposite because it is true because I'm taking the decision. So maybe I am not. Well, maybe not. I am not taking into account a lot of things that can be taken into account. But this can be considered because this, for example, is implemented in the emergency management model that and it's a Python script, so it's you can add.
That's why I surprised me that it's not on that way because it's important. It's a more important. And there's also something else regarding this. So it's for the execution. So this is all executed like offboard.
Sorry?
Executed somewhere else, and then send the instruction to the US, as far as I understood, right?
Can you repeat, please?
Where is this
Executed.
executed?
This function
Yeah,
in the
whole logic and the whole execution is of both.
is on cloud.
It's on the cloud.
Well,
you just send the commands to the US.
Well, it's implemented in a computer, okay, in the UTM framework, okay, in the ROS framework.
Okay.
We have different modules, and the module that decide what is the best action is the emergency management module.
Okay.
So it is implemented in this UTM computer, in the setup. Then you have here an interface that gives you the input that you need for taking the decision, and you got the output. What are the output? The output can be a command, can be an alternative trajectory, or create a volume. So the interface was made with other partners via the message that we share was JSON message. You know, JSON message. So we here in our case we were sharing ROS messages. Then we have a little module that you can convert ROS message to JSON. Okay, and then by using MQTT protocol, we communicate via internet with the server of the server that this company that I was assigned with, they develop a human matching interface for the project. We send our proposal or our output to there. And in this experiment at Atlas, for example, Satway was deploying this server in Greece because it was in pandemic time, so they couldn't come to the experiment. So it is also validated that they were far away from us.
Okay, so I see. Okay, I want to. So now I think I understood. Refer to this. So what? Since everything is computed in the cloud, as I understand, so the US only receive commands to follow some track, right? Is that
You send to the US operator,
okay,
and you send or a command or an alternative trajectory or create a geofence. Yes, that's correct.
So that is related to the question of Arturo. That's what happened. So since everything is in the cloud, because you said also an answer to another member of the committee that everything should be done in the cloud, right? It should be done in the cloud. What happened is something there's a sudden unexpected conflict in between. Another conflict is related to the question that I said. So you have not a cascade. It's just you're doing it. You are resolving a conflict. You have a conflict inside. So
It's difficult this happen because it's working well. It's working very fast in real time.
so you think that would be like not feasible, but it's not impossible.
It's very difficult to with maybe with more drones, very close.
Because it's also related to another question I have here.
I don't know. Maybe they want to say something.
Was about the same case. So you said that you were proposing to have this analysis done two by two, that it will happen that you have another third, and then how do you solve the conflict? The three of them, or first these two, and then whatever decision is taken is fixed, and the one needs to react to that one instead of having the three there. Because if you start with the other two, another pair, then the solution is going to be different. And that's why I was saying that the solution that is not necessarily optimal for the train, because it depends. But okay, it's an approach.
Okay.
Because my question was also related because I thought that you were using some optimization approach for this. You understand that correctly. So everything, even the geometry, the volumes that you are using, are all deterministic or are stochastic?
When I developed this, there was not. Well, I think that there is not still a definition of what should be the operational volume that you consider, because I was thinking it is not the same operational volume for a fixed wing that for a rotary wing. It is not the same operational volume for a M600 drone that for a DJI small drone. But I could not find a standard. And I also say to this to Eurocontrol in the review of the CONOPS that there is not I could not find a standardization of what is the operational volume for. And I think it's difficult because, as you said before, it's going to be a lot of kind of UAS. So you need to calculate the operational volume depending on the feature of every UAS. For be efficient in the airspace, no? You are not going to have a...
So it's not defined now, okay. So, but for your thesis, you have considered the volume like something deterministic.
Yeah, a buffer. Yeah, it's just a deterministic buffer.
So it's nothing. It's not like your drone is here approximately, like some Gaussian or something like that, some stochastic way of defining the position of the drone.
No.
It's different because that's something that they should. Because I know, I mean, they in the server, the US server that we have a position of all their objects, they never have a deterministic way. It's kind of something stochastic. So how will you resolve that? I mean, you have to put this surface, you need to know which is the buffer of that surface. When you have many, two is easy to hold. More than that, you have a lot of uncertainty.
There are also something that we are not considered. That that is, for example, the effect of the wing, because in the experiment when we took the result of the telemetry in the experiment, you could see the fixed wing and it was not going. It was like this. So it was very. For me, it was the first time seeing that, okay, you have a flight plan, but you are making like this. Okay, you are in the operational volume, but depending on the weather.
My first question was with that. You define operational volume, but how do you know that the object and the US is inside that volume? How can you guarantee that?
Well,
not in the regulation.
There is one of the threats that is that the UAS is out the operational volume, and then there is a conflict that you need to handle. If the UAS is out the operational volume, then emergency management will provide to the UAS operator a command that you are outside your operational volume, so please come back to your flight plan. But maybe technically cannot go inside because the weather don't allow Mhm.
Yeah, I see that there are many missing points in the regulations. So of course you did what you did with the clear framework. So I think that was good starting point. So but this is, I mean, I see the problem globally. For me, if I just put all the variables here, this is not non-solvable. But is not a solution for this. Okay. So that's why regulation gives us always a way to find a solution, because the complexity of the problem is too big. So at the end, from my point of view, I want to know your opinion. From my point of view, this is today and probably in the next 10 years going to be a matter of regulation. Is that am I true, or there is something that you think that has to be tackled also at the same level than regulation?
Well, no, I think that there are more things. You need a regulation, you need the telecommunication infrastructure, you need technology to make this problem to be solved technically. You need, you need a new, well, there are already new drones in the market. I think that it is a sector that it's bringing a lot of potential business case. And I think that the regulation is going to advance behind the technical people, because, for example, we want to make a. Well, I'm not going to say this, but we want to make a, because it's confidential. We want to. If you want to make a operation, I don't know, with an air taxi in Barcelona, okay. So you are going to the council, you are going to the EASA, you are going, and then you no, and then it's like a negotiation. Then you come with the technology, and then they come with the regulation, and the regulation. This regulation that I show here is just the beginning of the regulation. Yeah. Now you have to deploy more, but it is. I think that it is a work from the university, from the technology center, from the regulation stakeholder, from the European Commission, from the companies.
Okay, thank you. I don't want to go into. I have all the questions related to the communication, because everybody has the weakest point of this so, and the communication also is linked with the regulation. You have to say, okay, you need at least your communication have to have these requirements. That's the minimum required to have some performance. So it's all linked, obviously, it's still a bit so okay, so well, I would like just to, I don't want to go deeper in any other one, so it's too long now. So I would like just to congratulate you, because this is a problem that is very complex, in my opinion, because it is too high. But we need to start doing steps, as you did with your contribution to the thesis. So it's a good start, and I think it's a good contribution for this sector. So thank you, and that's it. So for now on,
thank you for the comment.
If anyone from the public wants to say anything, Technical, please.
I will ask him at home, because he will kill me if I do it here.
Okay, so no then. So from now we will do a little break and start the delivery. Very break. Okay. So okay.
Just a detail about the discussion about ROS. What is defined in the thesis is the framework architecture. So you define interfaces, you define the functionality. So then as a proof of concept, we decide to implement it with ROS for fast prototyping, which you might use different things. You're going to deliver an industrial product or whatever. But the idea is that even with ROS 2 is following the industrial standards, and so supposedly companies, particularly are using second version of ROS, which should be easy to debate here. So
Yeah, that's
not discarded.
that's the money is very it rolls through at the end. It's just an updated version of the other one.
Because the thing is the same layer, but then underneath is implementing a different stuff. It's implementing DDS or whatever, and you could select what is implemented.
That's good. So okay, so we'll do a short break, Nicholas. Okay, 5 minutes, and then start the delivery. Okay.
Okay. Para la grabación. Para la grabación. No,